Matthews Gatos here. In this video, we're going to cover factorials. Before we get into factorials, though, let's review what we've done so far. With the fundamental counting principle, we've done questions like this. How many arrangements are there of 3 objects? So I have 3 different stages. My first choice would be the 3 objects. Once I select that, I know that there will be 2 choices and then 1 choice remaining. So when I'm arranging all 3 objects, notice what I do. I start at 3 and multiply by consecutive but decreasing factors, and I stop when I reach 1. Let's try another one. Let's say I had 5 objects. So if I have 5 objects, I have 5 choices for my first one. After I choose it, I have 4 choices, and then 3, and then 2, and then 1. So again, I'm arranging all 5 objects, and notice I start at 5 and I multiply by consecutive and decreasing factors. I stop when I reach 1. Well, let's use that idea to arrange n objects. So to arrange n objects, I would start with n, however many I have, and I go 1 less, n minus 1, and then 1 less than that, n minus 2, and then 1 less than that. And since I don't know what n is, I just keep on going, but I know that I'm going to stop at n. So when I have n objects and I'm arranging all n of them, I start at n and I multiply by consecutive decreasing factors. I stop when I reach 1. Well, this idea of starting with a number, decreasing by 1 each time, ending when you get to 1 is called a factorial. Now, factorials are used when we're arranging all of the objects. So it's written as n exclamation point. N exclamation point in math means a factorial. So starting with the number and multiplying by decreasing factors, stopping when you reach 1. A couple of things you need to know. You can't take a negative factorial. And then these 2 special factorials. 0 factorial is 1 because there's only one way of arranging 0 items. Similarly, 1 factorial is also 1 because, again, there's one way to arrange 1 item. So you can't take a negative factorial, and I'm going to add to that, you also can't take a decimal factorial either. It has to be a whole number. So let's look at where we find that factorial on your calculator. On your calculator, if you hit your math button, go over to probability. Option number 4 is the factorial. Now on the color calculators, the CE calculators, you have a shortcut. You can just enter in alpha window and it will be option number 9. That's where the factorial button on your calculator is. So let's try some questions with factorials. So just a nice basic one with numbers. 8 factorial divided by 5 factorial. So we're going to do this by hand. My tip to you is to expand the bigger factorial until it matches the smaller factorial. The reason that we do that is because the only way you can cancel a factorial is with another identical factorial. So this one here is bigger, so I'm going to expand that one. So I start at 8 and I go 1 less is 7, 1 less is 6, 1 less is 5. Ooh, I have a match, so I'm going to stop there. 5 factorial all the way down to 1. And I have a 5 factorial on the bottom. So on the top, I do have 8 factorial, which is 8 times 7 times 6 times 5 factorial, which continues to 1. But I now know 5 factorial divided by 5 factorial is 1. So I'm really just left with 8 times 7 times 6, which I can plug into my calculator and get 336. Now let's take that idea with numbers and let's try it with variables. So if I have n plus 1 factorial over n minus 1 factorial, I expand the bigger until it matches the smaller. So I'm going to start with my bigger factorial, n plus 1. So I start with the first factorial and then I go 1 less. Well, 1 less will be n plus 1 minus 1. And if I do n plus 1 minus 1, that's just really n factorial, because 1 take away 1 is 0. So that's n factorial. And then I go 1 less than that, which would be n minus 1. And now I have a match, so I'm going to stop. Because it matches, I can divide. The same thing divided by the same thing cancels is 1, so I'm left with n plus 1 times n. I'm okay if you leave it that way, or if you want to, you can distribute the n in and say it's n squared plus n. Either is fine. Well, you can check anything that you do on the calculator. So in the original equation that I started with, expression that I started with, n plus 1 factorial over n minus 1 factorial, I can put that one into y1. Then I put the answer that I just got into y2. Now, whenever you check anything on the calculator, the check always happens in the table. So I can see for all the permissible values, the ones that don't have restrictions, I see that y1 equals y2. So that tells me that I simplified it correctly. Let's try another example. So in this one here, I'm going to go back to fundamental counting principle. I'm going to arrange 3 objects. So if I have 3 objects, A, B, and C, I want to know how many arrangements there are. So I have 3 choices for my first object, 2 choices for my second, and 1 choice for my last. Altogether, that would be 6 choices. 6 different ways of arranging 3 objects. Well, let's list out those arrangements. So I could have A, B, C, or flip the last 2 around. I could have A, C, B. I could have B, A, C, or interchange 1 and 2. Or the last 2 here, I could have B, C, A. I could also maybe start with a C, and I could have C, A, B, or flip those 2 back around. I could have C, B, A. So there are 6 different arrangements of 3 objects. So I have them over here, and I want to now try what happens when I replace every B with another A. So I'm going to have basically 2 A's and a C to arrange. So I replace each B with another A. So that becomes an A, this will become an A, this will become an A, and so on. I want to know how many arrangements I have. Do I still have 6 arrangements? Well, looking at that, I can see some doubling up. For example, this one arrangement here of AAC is the same as this one, so I wouldn't count that twice. This arrangement of ACA is the same as that. And this arrangement of CAA is the same as this. So I actually don't have 6 arrangements. Because I have 2 that are duplicated, I now only have 3 arrangements. Well, let's see why that is. Whenever you have permutations with arrangements, if there are n objects where A are the same, B are the same, C are the same, etc., you have to divide by the ways of arranging those identical objects. So when there's duplicates, always divide by the ways of arranging the repeats. So let's go back over here and see if that works. So I have 3 objects to arrange, which is 3 factorial, divided by the 2 factorial ways of arranging the identical A's. Let's see if that works. So 3 times 1 less, I'm going to stop because I have a match, and I get 3. So yes, that formula works. So a couple of tips with this formula here. First tip is this formula is only going to be used when you're arranging all the objects. So if you ever have a question where there's repeated elements, you're always going to be arranging all of them. The other tip that I have for you is the question isn't going to remind you to do this. It's just going to ask you to do the arrangements. You need to remember to divide by the ways of arranging the repeats. Let's try such an example. So in this example here, I want to know how many arrangements of the letters in the word red deer begin with exactly 1 R. So you can see I have it set up R and then not R for it to begin with exactly 1 R, and then anything that follows after. But hopefully you notice in the word red deer, there's some repetition. So I have 7 letters. 2 of them are R's, 3 of them are E's, 2 of them are D's. So I'm going to figure out the question as I would without a repetition, and then divide by the repeats in the last step. So I begin with an R, and there are 2 choices of R's. In the word red deer, there's 2 that are R, there are 5 that are not R. So I place those to fill in the remaining 5 letters. I know there's 5, 4, 3, 2, 1 choices. So to simplify this, I would do 2 times 5 is 10, times 5, 4, 3, 2, 1 is 5 factorial. But I have to divide by the ways of arranging the repeats. So I divide by a 2 factorial, a 3 factorial, and a 2 factorial. So I can put that into my calculator using the fraction template, or make sure you have brackets for the numerator and denominator when you divide. So when you plug that into your calculator, you should get, there are 50 arrangements. So figure out the question as normal, as usual, and then divide by the ways of arranging the repeats. Here's another example, an adaptation of the repetition question. Teo lives 3 blocks south and 5 blocks east of an ice cream store. How many ways can he walk home from the ice cream store? So this is kind of like a grid map view. Well, to illustrate this, what I'm going to do is I'm just going to trace out one possible route. Now, there are several routes. We're going to find out how many there are altogether. Here is just one possibility. Let's say he kind of zigzags through. Let's say that's one route that he goes. If I wanted to describe this route using S for south and E for east, I can say he went east, and then south, and then east, and then south, and then east and east, south and east. That's only one possible route, but I could switch around those and go in a different way. Like I could switch around these two and go east, east, and then south, and that would be a new route. So I want to come up with all the routes. And basically all the routes are arranging the 8 letters. 3 of them are south and 5 of them are east. So to do that, I would do 8 factorial ways of arranging all the letters, and then I would divide by the ways of arranging the repeats, which is 3 factorial and 5 factorial. Again, I can do that on my calculator by doing 8 factorial on the top and divide by, in brackets, 3 factorial times 5 factorial on the bottom. And when I do that, I'll get an answer of 56. So permutations are arrangements, ordered arrangements of all or part of a set. I can use factorial if it's all of the set, but part of the set I can use as NPR. P stands for permutation. So P stands for permutation. And if I'm looking at the permutation of n objects, this is the total number of objects, and R is how many that I'm taking, I can use this formula on your formula sheet. NPR, the permutations of n objects taken R at a time, is the ways of arranging all of the objects, n factorial, divided by n minus R, which is the ways of arranging the objects that I don't pick. So I arrange all of the objects divided by the ways of arranging the objects that I don't pick. Now, any question that you do a permutation with, you can use the formula, you can use fundamental counting principle as well. To get into that probability notation, we're going to go back into that math menu. So if you go math and over to the probability tab, the second option is your permutation button. On your calculator, if you have a CE calculator, a little bit of a quicker way, you can just go alpha window and it's option number 8. So remember, any question you can use fundamental counting principle for, you can use your NPR button for. So common permutations that you're going to see as you kind of go along, may be worth memorizing so you don't have to plug them into the calculator. The first one is NPN equals n factorial. NP1 is equal to n. And NP0 is equal to 1. And I have some examples of what the calculator screen would look like for n being 5. So it's something that comes up from time to time and definitely worth memorizing. So let's end with this question here using the formula and what we know about factorials to simplify it. So if I want to solve for n where NP2 is equal to 56, I'll use my formula. So n and then 2 is r. So I'm going to replace this here with a 2, and I know the whole thing altogether is 56. So let me write out my formula. NPR equals n factorial over n minus r factorial. Now I know that NP2 is 56, and that's the same as n factorial over n minus r is 2 factorial. So I'm going to simplify this just like I did with my expressions. I'll start with this one here, and this is the bigger one, so I'm going to expand until it matches the n minus 2. So start with n, go one less again, and I can stop because it's a factorial and it matches. So that cancels. So I'm left with 56 equals n times n minus 1. So I have a nice quadratic that I'm going to use to solve. So remember, when you're solving quadratics, you want to expand by distributing it in, and then set to 0. So I'll just subtract 56 from both sides. So now I just have to factor this quadratic. So I'm looking for two numbers that multiply to negative 56, add to negative 1. So that would be negative 8 and positive 7. So I know if n minus 8 equals 0, I would have a solution of n equal to 8. And if n plus 7 was equal to 0, I would have a solution of n equaling 7. But remember, you can't have a negative number of items. So remember, the n that we're solving up here for is the number of objects. So I know n can't be negative 7. You can't have negative 7 objects. And then I'm just going to write down the word extraneous to show it is a solution to the quadratic, but not the original equation. So I get a solution that n is 8. Every question that you do, I want you to always check. So I just want to check, is NP2 equal to 56 when n is equal to 8? So I'm going to go onto my calculator, and in Y1, I'm going to enter in NP2. And I always go to the table, because the check is always going to happen in your table. And so I can see in the table there, I'm looking for what happens when n is 8. Is it equal to 56? And you can see when x is equal to 8, y is equal to 56. So I know I solved that correctly. So many of you know I really don't like to cook. It's probably one of my least favorite things to do. So this is a typical conversation that happens in my house, say on a Friday night when I've been working all week. Okay, I yell upstairs because I don't want to cook. How many pizzas should I order for dinner? And then my teenage boys yell down, I'm so hungry, I could eat 3. And then I say to them, there's no way you can eat 6 pizzas. And then there's a long pause. And then they realize 3 factorial, 3 times 2 times 1 equals 6. And then I usually get, good one, Mom. So I hope that this video helped. If it did, give it a thumbs up so we can help more mathies. Hit subscribe, and I'll see you for the next one.